Good morning. Today we're going to work on arithmetic and geometric series. A series is the sum of the terms in a sequence, okay? So when I'm looking at this, I'm going to use the sigma notation here. That first, we're going to say the term down here is going to be the first term, okay? Then the term up here is going to be the last term, making sure that you're stating what position it is, not the actual value. And then here we're going to put our explicit formula that we've already worked with. So as I look at number 1 here, they give me a sub 1 is negative 2, and a sub n is defined by a sub n minus 1 plus 5. So using the recursive, the one less time, and then we're adding 5 to it. So in this one right here, the value of 5 up here tells me I'm going to have 5 spots. We're going to add those together. So the very a sub 1 is going to be here, a sub 2, a sub 3, a sub 4, and a sub 5. That's plugging in the 1 in for each of those spots. So a sub 1 is negative 2. When I go to find a sub 2, that says use the one less position, so a sub 1 plus 5. So negative 2 plus 5, that's going to be 3. A sub 3 needs to use a sub 2 plus 5. So a sub 3 is 3 plus 5, or 8. A sub 4 is going to equal a sub 3 plus 5. So 8 plus 5 is 13. And then the last one, a sub 5, is a sub 4. A sub 4 plus 5, so that gives me 13 plus 5, 18. Now I add all of those up, and I get a total of 40. The next one, we're going to now be multiplying. We can see that we're going to have 5 terms again. That's from this right up there. And a sub 1 is going to be 3. A sub 2, multiply the previous term by 2, so I'm at 6. A sub 3 is 12. A sub 4 is 24. And a sub 5 will be 48. Those are my 5 terms. Add those up. Oh, I'm so sorry, you couldn't see that. Those are my 5 terms. Add those up, and you're going to get 93 for that one. So now we're asking us to find the sum. Hold on, don't worry, okay. Find the sum of the terms that we have below right here. So first, looking at this arithmetic meaning add. So as I add the terms, I can see that I'm adding by 3. So that means my D value is 3 for this specific set. My first term is 5, so a sub 1 is 5. And it's going up to 77. I don't know what spot that is, so the first thing I'm going to do is use my formula and find out what position that is. So first, a sub 1 is 5. The n is what I don't know. The d is 3. And I'm looking for whatever spot 77 is. That's my a sub n. So then, subtract 5, 72, equals n minus 1 times 3, divide by 3, n minus 1 equals 24, add the 1 over, and I get 25. So what that tells me is that my a sub 25th term is 77. So when I go to set up over here, I have that lovely e, and I'm going to say, all right, I'm going to start at the first term, n equals 1. I'm going to go up to the 25th term, which was the 77. Remember, we're putting the place, not the value. And then I need to use this formula I already wrote here. So my a sub 1 was 5 plus n minus 1 times 3. So now I could put that in like I've been doing, but I'm going to use the calculator to help me. So first you're coming over here to the one that goes from 1 box to 2 boxes, and that pulls up all of the ones you're used to, and you're looking for the summation right there. It's the funky looking E. Okay, and I used n, so I'm going to continue with that. So n equals 1, and then in the box right here I'm going to write 5 plus, open a parentheses, n minus 1, close a parentheses, times 3, and then go up to the top and tell it you want 25 terms. Hit enter, and magically we have our answer of 1,025. That is the sum of my first 25 terms. So now, the next one, sorry guys, the next one we're going to do is geometric. We know geometric means multiply. So as I look here, I can see, labeling things, a sub 1 is 6. I am moving a sub 1 to a sub 2 to a sub 3 by multiplying by 2. So I say my R value is 2. Same problem I had before is they gave me what the last term's value was. They didn't give me the actual term number. So we're going to set up another formula that we'll need. So this is the other one you do have to have memorized. Okay, so a sub n is this 768. A sub 1 is 6. R is 2 to the n minus 1. First step, divide by 6. And that gets me 128. Then I'm in a position where my exponent is in the sky. I can't have that. I'm going to go switch to logs. So I go from exponential to log. Log base 2. That 2 is holding up the n minus 1, so that's my base, of 128 equals n minus 1. I'm going to type log base 2. Remember that that's right, it's somewhere. Right there, so you're going to do log base 2 of 128, and I get 7. Love when they're perfect numbers. So 7 equals n minus 1, and n equals 8. So another fact I can now add is that the 8th term, n sub 8, is 768. So now to find the sum of those terms, we're going to say n equals 1. We're going up to the 8th term, and I'll have 6 times 2 to the n minus 1. Type that right in, and I will get 1,530. Okay, always great to have specific, just arithmetic and geometric. More likely, we're going to have a situation, hopefully in the real world. So we have here, Kirk has set up a college fund for his son Maxwell. He's going to start by depositing $100. Okay, so that right there, the first deposit he makes, that's our A sub 1. And he's going to increase that deposit by $10 each month, meaning month 1, $100, month 2, $110, month 3, $120. So as I look at that, that's increasing by an amount that's added, so that's a D value. So as I set up over here, A sub 1 is 100. D is 10. So I'm going to write that formula out that it would be 100 plus n minus 1 times 10. There we go. And they want to know how much he will have in the account after 10 years. So I set this up starting x equals 1. Over here, I write my formula, 100. Since I just switched to x, I'll switch to x right here. Here's the trick of this question. We started talking that my unit of time was months. Now they want to know 10 years. So there's 12 months in a year, 10 years. That's going to be 120 times that we check in. And then type that in. How much will he have in the account after 10 years? 83,400. Okay, one more example here for tonight. All right, we start with $500. We're earning at a rate of 5%, and it says compounded annually. Okay, so once a year. We want to determine how much money she'll have at the end of 10 years. So the first thing we're going to set up, notice the A of T. Remember, if they give me some kind of labeled value, we have to go with that. We don't want to just say Y. So we have our initial amount of 500, 1 plus my R. So first I took the 5%, turned it to 0.05, add that to the 1, there's my T. Okay, write a geometric sum representing the amount of money they will have after 10 years. So we're going to start right here, and we're going to say we have to include that initial 500. So I'm going to be starting at 0 time, and we're going to go 10 years. To the X, type that in, $7,103.39. All right, guys, have a great night. I'll see you tomorrow.